Alright, what's up guys? Oop, I gotta fix the title. 3 to 4. Alright, so today we are getting back into algae. Yeah, I'm just gonna keep going through it. Let me hop over here, turn on my recording, and let's pull up the Go version. So basically, one of the thoughts I had this morning was just to go ahead and knock out a bunch of these small files before we get back into the more intense ones. So where we ended last time, we were in main, and we had the basic skeleton. Let me switch sides. We had this basic skeleton in place. So we've actually, I believe we finished the context, and we may have even finished the scanner. Is that right? Yeah, I think we also finished scanner. So we set up a skeleton of the parser, basically just enough to get this this main function to compile. So we made a parser struct, we made a new function, and then we added this run thing that pretty much doesn't do anything and just returns an error right now. So that's the main thing we're going to be tackling. But as I said, let's go ahead and let me try to remember how to use embark. Kill buffer. Okay. Let's go back to our README and try to knock out a few of these tiny files. So for example, you can see opdef is just one struct definition. So let's go into our exec. Let's see, exec. So they have a module for it. Well, what we would call a module, I guess. Pubmod opdef with a single struct definition as a name and is binary. And we're not going to use that yet, so we'll annotate it with that. Okay, now we can check that off. And then let's go look for parse exec opdef. This looks exactly the same. Let's see if this is actually used anywhere. No. No, it's not. Is this one used anywhere? Okay, this one is actually used. So we'll go ahead and say X. And then what I've done in the past, whoops, is we can add another one that says like notes. We'll just say unused question mark here. Even though it's fairly clear that it was unused. Let's go look in run, time Unix, R usage time. Does this call R usage? Let's see what this is. Great. Provide measures of resources used by current process. Oh, I forgot to add the chat to all the windows again. Let's see if we can get something like this. libc. I'm not really sure. Why would we even do this? Is this used anywhere? No. Okay. Let's not be so uncertain. Let's just say they're both unused. Okay, I'm expecting operator to be used. Let's look for operator.go. So this is in exec. Let's go back to exec. What modules do we have in here? Oh, okay. Apparently, iMenu doesn't know about that. Ooh, sorry about that. Let's add another module, pubmod operator, and we'll just have some pub functions, pub fn. Let's see, context. It's kind of weird. That's an exec context. Interesting. Okay. Pub fn predefined. I thought, oh, we have this up here. Oh, this is supposed to be in the operator module. Okay, let's just put this down here. That will probably break our code. No problem. We'll fix that in a second. Okay. This is weird, but we can do this here. Let's just make sure we don't have this anywhere. Oh, it doesn't look like it. Where is this defined? Is variable. I remember writing that. If c dot is variable op, return false. Otherwise, we'll return predefined op or binary fn. Oh, this isn't pub. So why does this take a string? Let's just go grab it from our other one. Great. Alright, we fixed that. Back to our README. Oh, wait. Okay, defined op. add some documentation. Reports whether the operator is predefined and built in. Oops. Reports whether or not op is known. Pub fn defined binary op This looks like you could combine this, right? So if c dot is variable op, return false. So if it is a variable, we're going to return false. So could we do something like not is variable and the rest of this? Something like that, maybe. Return false. Otherwise, we return self.binary fn op. Contains key op or self. No. Oh, now we have to do this built-in thing. Value binary ops. Yeah, don't we have is binary op? What does that do? Yeah. Okay, I think we can use that here. Probably we should, this should probably have a better name so it's clear that it's a built-in, but I think that'll work. Okay, so either it's a binary operation defined in the current context, or it's a global binary op. Okay. Reports whether the operator is a known binary. And this, we'll just copy this. If C is variable up. Oh, we don't have one of these yet. This is at the top level. Perfect. Back to exec. Oh, we need to import it. Great. Okay, so that should be it for operator.go. Back to our README. Alright. Well, let's see what that got us. So what's this? 50 plus 38, maybe 80 lines. So maybe we got, do we hit 9%? Almost. Alright, let's look at type string. Oh, that's kind of cool. That's funny. Yeah, so this... Wow. Yeah, this is string. Okay, so this is just impl display for type. Struct type. What? Struct. Oh, it's an enum. Ours is an enum, of course. Pub enum type. Yeah, so this is just impl display for type. Alright, let's do some fancy replacing here. Okay. So we will, oh wait, and then dot star. We'll just put type 1 arrow. Perfect. And I guess we'll make EOF capital in the string. EOF, this is kind of goofy, huh? EOF, error, new line assign. I'm just seeing if there's anything weird. Semicolon. No, I think that all looks good. Alright. Type string. Done. Demo test? What is this? So I think this is actually, this is like our only real test. So we might want to hold on to that one. We'll do that one later. Do we hit 9% now? Oh yeah. Okay, demo test. So that's kind of a hold off for now. But isn't everything we've not written so far a hold off for now? Okay, let's look for parse assign. Implementation of a value that's created as a result of an assignment. Okay. Value. Let's save this. Value. Oh, this is parse. Value is an enum. So this is, yeah, it has an embedded value. Okay, yeah, we might, no, we can probably do this. Implementation of value that's created as the result of an assignment. Type asserted to discover. Oh, that's kind of neat. Kind of neat. Are we going to do that? We might not do that for now. Implementation of value is created as a result of an assignment. So what I'm thinking right now is our value type may become a struct instead of an enum. So we might have something, we might end up with this being called something like value type, and then we'll have pub struct value that contains a value type, or probably actual value, and then it'll have like is assignment, something like that. We might end up with this later on, but right now we'll pass on that for now. Embed this as value type in a value struct that also contains is assignment field. See parse. Okay, yeah, good question. So what is Ivy? I think, let's see, I think I still have this set up. So we can run Ivy. Ivy is an APL-like language, which basically means it's a little calculator, or a little, I mean, I don't want to call APL a little calculator, but it's an array-based programming language where you can do stuff like we can make a vector, 1, 2, 3, and then let's refer back to that vector, and we can add like a number to it. So basically, most of the operations extend to vectors or matrices. I'm not actually sure how you can... Oh, I guess you probably have to do... let's do row 2, 3. Or maybe it's 2, 3 row iota 6. So basically what we did here, iota 6 gives you the numbers 1 to 6. And then we can reshape them... Oh, whoops. Oh, I don't have RL wrap installed. And I accidentally closed it. But it's a little calculator language, and yeah, it's pretty cool. I think, do I still have the link to? Maybe I can't see it. Yeah, if you want to see it in action, go check out Russ Cox doing the Advent of Code in Ivy from last year. It's really cool. If you've never seen APL, another cool thing you can look up is like APL Game of Life. There's a video, I think this is the video. You see it's an 8-minute video. And if you don't know what the Game of Life is, look that up too, because that's really cool. But basically, you can write really intricate programs in a very small number of characters because it has a bunch of really powerful operators. Yeah, so this is the Game of Life, which is actually a pretty complicated program in one line of APL. So APL is really cool for data analysis and stuff like that. And Ivy is kind of a minimal implementation of an APL. And we were trying to convert it to Rust because it's written in Go. Okay, we're going to hold off on that. Value loop. Let's look for loop. Big float. Okay, so I think we knocked out kind of the low-hanging fruit up here, and the rest of this we'll probably come back to as needed. So let's just check this one more time, and I'll go ahead and commit this. Okay, now with that done, we can go ahead and hop back into main. So let's go to run. Ivy eval. Okay, so we actually have this run function already. So let's go up here. So I guess this means value.iv-eval. So you can actually change the eval function, I guess. But anyway, let's go ahead and jump into this. Pub fn iv-eval takes a context, and it takes stir, which we can't actually call stir. Where is this coming from? This appears not to be called anywhere. Okay. Okay, well, we'll forget that then. And just jump straight back down into run. So we've got our conf, our config. We've got our writer, which we're not using yet, which we did straighten out with all of this trait bound stuff. We can't do this defer. If conf.debug panic, just return. So this is just trying to recover from a panic. Okay, we'll skip that for now, and we'll just do this. Okay, so we'll keep W, loop, if interactive, okay, we can use that. we're going to write the prompt. Write w conf.prompt. We'll go add that function. What? Oh. Config prompt. Where's prompt? Oh, I'm in the wrong place. Config prompt. Let's generate a getter method. Still not working. Not sure what's up with that. Prompt as ref. Back to run. What's wrong? Oh. Oh boy, here we go. Yeah. Find this reference. So this comes from conf. Okay, so we need to go back over here. This has to take ref mute self, and it has to return a ref mute output. And now this has to be mute, which means that this has to return, this has to take ref mute self. Oh boy. Self.config. Oh. Oh, okay. Makes sense to me. Can't borrow data in this as mutable. No way you can say this is muted here, right? Or do you? Okay. Does this type check? Unreachable. Cannot borrow as mutable. Yep. Mute. That should be fine. Cannot borrow as immutable because it is also borrowed as mutable. Yeah, we probably need to as mute ref as ref. There we go. I don't think that's going to save us here. Yeah, because we keep borrowing it once at a time. First borrow occurs here. Yeah. Okay, we're just not going to use these. We are just not going to use the methods. Okay, so conf is context.config. Actually, we might just, no, we don't want to undo everything. Well, maybe we do. All right, I'm just going to discard my unstaged changes because I don't like this. Okay, let's go back up here. Put interactive in. If loop, if interactive, then we're going to take this W, not that, write W conf.prompt. Okay, so this is private. Make it pub. Now W needs to be mutable. Okay. And let's just get rid of that as well. Just access the field directly. Take a mutable reference to that. But then, okay, just forget this. We'll just access the config directly. Whoops. Pub. Okay. Does that work? I don't think so. No method. I guess I didn't have to delete the cannot borrow. Okay, because it's borrowed from context, so this needs to be mute. Oh, of course. Oh no. I really don't want to have to clone this. I'm sure I'm doing something dumb here. Oh, I just have to borrow it. Regular borrow? Okay, maybe. Consider... Okay. I thought I tried that. Oh, maybe I have to borrow this. Can't borrow this. Okay, and there's no help for this one. Okay, so conf is a mutable reference. Oh. Oh no. Oh. Context might just have to hold a config. Let's try to figure out. Let's go back to main. Context. We use this config. No. Okay. I think we can make our context just hold a config instead of a reference to a config. Okay, let's go down to new. Okay, you're just gonna hold a config. Well, that's just not true, right? Or is it? Maybe it is. Okay, mismatch types. What? Oh, okay. Ooh. Okay, that's not good. Wow. So those are supposed to share. Oh no. This is so bizarre. So we give our scanner a reference to this context. This doesn't make any sense. So I think, let's see. I think this scanner should be created inside of run. Let's go back to ivy.go. Because if we take a mutable reference here, we can pass this mutable reference into run, and then inside run we could create this scanner. So let's try to figure out why it's not done like that. So scanner is just created right here. It just gets handed to the parser. Yeah, I think both of these should just... does this get called somewhere else? Run string. Oh, that's why. Context, but the scanner takes a context. So I think the scanner should always take the context. Oh my goodness, they all take context. Oh. Okay, the other thing we could do is we can use a cell. Because I think this... Well, no, I mean, the context just has to be mutable, right? Context eval. Yeah, because you're evaluating this stuff. Eval. Yeah, I think you're going to be modifying the context. Oh boy. Hey, how's it going? Yeah, what time is it? Right now it's 10:37 a.m. Oh boy, this is not going well. Okay, cannot borrow context. That makes sense. Okay, yeah, where are you? For it to be nighttime. Maybe, let's see, 10:30. So you could be in Europe, or, let's see, where else? I mean, I guess... Asia? Something like that. Ref mute context. Oh, okay, nice, nice. GMT +7. Oh, gotcha. I think, what does that make me? I think I'm GMT -5 or something? I'm not really sure. I don't usually think about it like that. How are we going to handle this? I think the issue, the root of the issue here is that I think these are all supposed to be the same context. Like the scanner can change the context, the parser can change the context, and running it can change the context. So this might have to be like would an RC? No, we can't. Not an RC. Because we need to be able to modify it. We're going to have to make this like a... We're giving out multiple mutable references. I mean, we're going to have to use like a mutex maybe. Or we're just going to have to restructure this. Because like I was saying before, I think inside of run, we could, inside of run, let's see. Yeah, we can't give out a bunch of mutable references. Oh boy. Let's see. So we're just looking at that. Okay, this is read only, read only, read only. Okay, it looks like this is actually... It looks like the scanner actually only reads. Okay, so the immutable reference here. So this is truly an immutable reference. Now the parser, I'm not even sure we know yet. Parse. This takes a context. Yeah, so assign local is definitely going to modify the context. Okay, so the parser needs, okay, so this really appears to be an immutable reference. Let's just try to write some stuff down. This needs to be a mutable reference, and so does this. Okay, so yeah, this clearly doesn't work. So, and especially the way it's written. So this parser takes, it needs to take both it takes a reference to a scanner, which itself contains an immutable reference to our context. At the same time, it's supposed to be taking a mutable reference to our context. Okay. Let's go look at the scanner. So maybe the one thing we might be able to do, we might be able to say that our parser contains a scanner I don't know. This might be beyond my capabilities. Let's see. Okay, again, cloning doesn't help us here. So this isn't like an optimization issue where we just don't want to clone the context. It's like we need to have the same context everywhere. And it needs to be mutable from multiple places. So, I mean, I think we just have to have a mutex. Yeah. Yeah, the best way to implement this is to redesign your structure so that you don't have to implement this. Yeah. Okay. Okay, we're going to try... Whoa, that was weird. We're going to try to restructure this. So the main thing to me here, I think we can take, if we have a mutable reference... No, that doesn't make sense. Alright. Anyway, my first idea here is just to move this into run. Okay, we don't know parser. Let's jump into run. So we're going to have these. We're going to have a scanner and a parser. We don't have to pass in the parser anymore. Okay, back to run. You're going to have to import scanner. Explicit lifetime required in the type context. This is a real disaster. Wow. Wow, this is a mess. I really hate how it puts the warnings at the top, because I want to look at the actual errors first. Wait, what? Oh, duh. Okay, that should be fine for scanner. Now, scanner. Scanner does not live long enough. Borrowed value. Scanner dropped while still borrowed. Context.config.prompt. Context.config.output. Yeah, we might just have to like completely rethink this whole thing. Scanner does not live long enough. Really? Where's it? Context is borrowed for tick A. Okay. Requires this scanner. Borrowed value does not live long enough. Lifetime, tick A defined here. Immutable borrow occurs here. Okay. Oh, let's try this. Yeah. Okay. I think we're going to have to move output and error out of context, or even out of config. I think those should just be arguments to run. Alright, I think we're going to discard our changes again. Okay, let's just reset one more time. Yeah, because the main issue here is, if we go back to main, when we jump into run, there's not really any reason for our context to include this config, I think. If we go look at config, output and error, they just don't really need to be in here. Yeah. So let's just look through this. So we could just pass in this writer. This is the only place we just immediately grab the writer from conf.output, and then we just use writer. Okay. Let's see. What do we ever call conf.error? Error output. This is in eval. Or no, this is in run as well. Conf.error output. Okay, so let's just get rid of that. Config doesn't really need to have this in it. We'll handle this some other way. If it needs to go somewhere else, we'll handle it a different way. I mean, where do we even set? Whoops. Output. Oh. Let's look at this. Output. It returns c.output. Does this even get set anywhere else? If c.output is nil. Oh. Init. Oh, if we call set output, do they call that set output? No, I mean, we just never even set that. Okay, this is like something to add later. Just forget all of this. Okay. Config. Alright, we're gonna have a lot of stuff to fix here. Output doesn't even exist. Get rid of this. Get rid of this. This is great. We can get rid of all this stuff. That we painstakingly added at the end of the last one. No generic arguments. No method output. Okay. Unused variable. Type annotations needed. Okay, so now if we go look at our context, we also don't need to have this. Now the function doesn't need OE. This doesn't need, oops. This doesn't need OE. This doesn't have OE anymore. Can't find type O, that's because it doesn't exist. Okay. Scanner doesn't need to have these. Yeah, so this is definitely one downside of Rust compared to Go, for example. I think the cost of trying something in Rust is much higher. Because you'll see, like, the number of things that we have to change is just gigantic. And I don't see like a really good way to do this automatically. So probably what I should learn from that is to think through this stuff more clearly in advance. But that doesn't really seem to be my main takeaway. I just do this. Okay. Okay. Did we get it? Almost. Whoops. Almost there, I think. Whoops. Can't find type O, that's good. And actually, we can play. I was thinking about this before. So we can actually, if we ever do want to redirect this stuff, like to a file or something, we can play some tricks with that. We can use like the dup syscall. That's what I use in one of my other programs. And we're still generic over the reader, which is good. That means we can like read from a file or something like that. We're just getting rid of this output error thing, because there's not really any reason to do this. Okay, type annotation needed. Great. Are we done yet? Type annotations needed because I didn't delete this. Oops. Okay. Whew. Okay, so we took care of that. Now, if we go back to main, we go into run. Let's try run again. Probably we still can't do it. So we've got our writer. So now we don't even have to mess with this writer stuff, right? We'll just say if interactive. Then we just print conf.prompt. Conf is a config. Let's go look at config. I need to make this its own file. Config. Yes, excellent. Now I can find config, impl config. We can get a getter. Fix the name again. Go back here. Run. Okay. Actually, let's give this a shot. Cargo run. Okay, well we don't have a prompt, but let's see. Let's go back to config. Let's make a new default prompt. Let's make it this. Okay, now if I run. Oh wow. Okay, we forgot to wait for input. At least something's coming out. That's pretty neat. Okay, great. Yeah, actually, let's keep that. Let's keep a little default prompt. Okay, so we go back over here. P.line. Oh, what is P? Oh, P is our parser. Okay. P.line. We need to go write that. Takes a ref self. Probably it's going to take a ref mute self. And it returns, okay, nil means there were no values. The Boolean reports whether the line is valid. Let's actually return a result here. Vec expr a nil return slice means there were no values. The Boolean reports whether the line is valid. Parse error. And then we'll just make this struct parse error. Okay. This needs to have some generics, I think. Reft in. Let's see where else we do that. Oh, not error. Expr. Yeah, reft in expr. We might need some ticks on there. We'll see. Alright, let's see what we got here. Var okay bool. If not self dot read tokens to new line. Return nil false, which means we return error, parse error. Which is fine. Let token be self.peak parser, so we'll have to write that as well. Then we'll match on that. Oh, the stuff that's, what's this? Okay. What's this? What? This is a tab? What the heck? Okay, so we got that. Well, we need to do peak. Let's do peak first. That seems more interesting. Peak. Why did I do that? We're not going to do that. Pub. No, this is not pub. This is just fn peak takes self and returns a token. If self.tokens.is empty. Whoa. Self.tokens.is empty. Then I return token new what? How do I make a token? Let's go look at token. Token. It has a new. Is that private or something? Oh, it is. Okay. Pub fn new. has a type EOF 0. Okay, else we return self.tokens 0. Great. So there's peak. Now let's do read tokens to new line. Oh, let's go back to peak for a second. What? Oh, there is no documentation. Perfect. Read tokens to new line. Fn read token. Well, we can just generate this. Returns a bool. I think it should have been able to realize that. P. So this has to take a mutable reference. Self.tokens equals token. I think we can skip that step actually. I think we're just. What is token buff? I don't think we can even do that. I think this is self.tokens.clear. So this has to be mute, which means that line has to be mute, of course. Okay, self.tokens.clear. Loop. Let talk be self.scanner.next. So we need to look at impulse scanner. Where's next? Next inner. Next. This needs to be pub, which was the whole point. Okay, dot next. What does this return? Okay. Match talk. If it's an error, talk.type. We might be able to fill this actually. Wow. Okay. If it's an error, then we call self.errorf. Now we gotta go look at this. Parser errorf. Format string. I think it takes called value.errorf. I thought we made this this takes a scanner. Oh, all right. We'll try to do what they're doing. We'll just say it takes a string. Doesn't return anything. We just truncate tokens. Truncate self. Self.tokens.clear. And then we call value.errorf, which is in value. Just takes a string. It looks like it just panics. What is this error? I think this is stupid. It just panics. But I guess we'll keep the structure. Panic, yes. Must be a string literal. Okay, fine. even bother with that, right? You call error F, which just panics. Panics with the formatted string. I still have a bad feeling that we're going to be catching panic somewhere. Okay, so error F is self.tokens.clear. Let's just go back. And then we panic with token. Panic. This is lame because how many times is this referred to? Oh, a lot. Okay, we better just we better make this a macro, I guess. Self.tokens.clear. Yeah, because it's so silly. We're gonna have to call this with this. Let's see how we can use this macro. Format args. Okay, let's try to write a macro. So it takes ref mute self. It takes, what is this in? Parser. I guess that's an ident. And then I think it takes the same thing as this. And okay, it expands to parser.tokens.clear. And then we're going to panic. This is the hard part. Format macros. Oh, this is a crate. Let's look. I kind of want to look at format. Maybe we can just look at the definition of format itself. How do I look at the definition? Source. Let's look at this. There we go. Okay, source. Format args. Oh, okay. That makes sense. Args. Does this work? Let's put it up here. Delete this. Does it work? I think it works. Ignores token pin. Wait, what? Is likely invalid in expression context. Oh, hold on. Ignores token panic and Macro expansion ignores token panic and any following. I'm missing a semicolon here. Okay, that makes sense. I guess we have to do this again. Great. Okay. Slightly annoying, but that's okay. Okay, if we hit a new line, we just return true. I'm gonna take the semicolon out. And if we hit EOF, return p.self.tokens.length greater than 0, and it'll probably tell us to use not self.tokens is empty. Otherwise, so those are the three interesting cases: EOF, error, new line. We return. Otherwise, we call self.tokens.append. Oh, I see. Okay, hold on. These should be returned. This should be returned. Otherwise, nothing. And we come down here and do this. Oh, this is supposed to be push, not append. Whoops. Great. Does that work? Okay. That's the only issue. Then, yes, it's working. Oh, no more coffee. Alright, read tokens to new line is done. Let's go back up to line. Here's line. Not self.read tokens to new line, return error. Otherwise, peek the token, match talk.type type EOF will return error. Oh, it's not error. Oh, it's just okay of an empty vector. Type right paren. Then we say self.special self.context. Oh boy. We're gonna have trouble again, I think. Okay. Expers. We can just make, that way I don't have to have vec new everywhere, right? Generate special method, kind of funny. All right, right paren, type up, function defen, and then we return OK expers. Else, then we say nil false. So we're either, okay, we're just going to return self.expression list. Okay, here we go. Alright, let's go look at special. I think it doesn't return anything. Great. So yeah, this this doesn't return anything. Self.need type right paren. Whoops. Generate that. Okay. Let con equal. No, we're just gonna inline that. Let ibase. I think we'll just inline that as well. Oh, good lord. These are the special operators. Where's this? Yeah, I don't know about this. Let's write this part. So this returns, this takes a scan.type. Oh yeah, it is a type. Just call it type. And it returns a token. Oh, this is in a different... Oh, we don't have next yet. Okay. Self.line none equals line. Okay. That diverges, and then otherwise we're going to just return public. I guess this is actually self.tokens. We want to like pop from the front. I guess let's just remove. I don't know. I mean, that you remove the first one, you have to shift the whole vector over. But at least we don't have to allocate a new vector. Not sure. We could use a DQ or deck. Whoops. I usually pronounce it. I guess it's spelled like this. Double-ended Q. I guess it's DQ. But just to rhyme with vec, I usually call it a vec deck in my head. If we had to do a lot of this type of operation, we could use that instead of a regular vector. Because then we could call like pop front, yeah. But I'm not sure if it really matters. So that's next. Good. what other to-dos do we have? Need is not done yet. Where did we come from? This, oh, this is a different file. So this one's actually variadic. So we might have to use, if we really want to emulate that, we could use a macro, or we could just have it take like an iterator or a vector. So we call self.next for w in self.want. Oh, okay. Let's just add it to do. To do, take multiple type and loop over it. But for now, we'll just do the inside. If talk.type equals type, we return talk. If this is kind of goofy. So if our error F implementation doesn't panic, then make sure we panic. Error F self talk. Great. Need, so this looks like it basically just loops until we find what we need. Okay. Special. Okay, we're not going to use the context. We're just not going to worry about messing with the base here. Well, I guess we can't really do this defer. I don't have a conf. So, oh, but it wants us to do self dot context dot config. But then we have to edit the config, which we don't want to do. This is crazy. To do should be changing base here. We'll figure that out later. Does this work? Function. Let's generate that. Hey, my day's going pretty well. Yeah, just doing some Rust coding. What could be better? We are having a little trouble. I don't know if you saw the beginning of the stream, but we had some more trouble with lifetimes and references today because the way the Go code's written, we're kind of like handing out a bunch of different types of references all over the place, which we couldn't really emulate. I think we made it past that for now, but we'll see. So things seem to be going okay right at the moment. This is in function.go. Function. How's your day going? This is in exec. So this is supposed to be, we're supposed to have parse function. Parse. I think we'll hold off on making this a separate module for now. We'll just do it in place. This doesn't return anything. Okay, so we're going to call self.need type op. Oh no. I guess we gotta go look at this. Can we derive default for this? I think we can. I think this has a default, vectors have defaults. Okay, so we'll actually do default for this. Okay, so obviously that's be mutable. Okay, 2 identifiers means op arg. 3 identifiers means arg op arg. Okay, let mute idents be. I think this is length 2, capacity 3, right? Great, it doesn't tell us, but I think so. Back, we'll just say with capacity 3. Okay, whatever. Well, it can't be. What are we? P.need. Wait, what is this supposed to return? Oh, okay. This returns a token. Okay, that's fine. Idents 0 equals self.need type identifier dot. What is this? Text. Okay. What's the problem here? Oh, right. Yeah, this needs to be like a token default, I guess. Token default? What am I doing? Token. What's the problem now? Oh, string. Oh, dummy. Wow. Wait, this also seems dumb. What am I doing? Vec. Why don't we just push? We will make this. This is vec. This is so strange. I guess what we'll actually do is this. This. Self dot, and then we'll just copy that. We need another identifier. Okay. So that's our first set of identifiers. Now we peek if self.peek.type is another identifier. I see. Now the comment makes sense. And we could add, yeah, we could have like a, we can make an is method, dot is identifier. Then idents dot push self dot next dot text. Self dot next. Yep, now it has to be mutable. Great. Now we let toke be self.next. Install the function in the symbol table. Okay. As if. What does this mean? As if. Like, do recursive ops not work? Okay, well, anyway. Let mute install map. We'll try to write it like this. We'll see what happens. Hash map new if idents.length is 3, if idents of 1 is this, poor choice due to outer product. So they're saying you can have, oh no, you can't. Okay. Self dot, no. Error. I keep forgetting we define it as a macro. Self. See, if we didn't have to have hygienic macros, we could just capture self. We could define like well, we wouldn't even have to define it in the in our impl body, but we could just write self in the macro definition, and then we could just say error f. But we have to pass in self so that we can call self dot clear. Error f self is not a valid name for a binary operator. Yep, we don't know what type the hash map is, that's fine. Fn is binary. We'll come back to that. Fun.left is idents of 0. Fun.name is idents of 1. Oops. And fun.right is idents of 2. So something that would be cool, did I not declare it as mutable? Left. Pub. Something that would be kind of cool is what's called, I think it's called point freestyle. So for example, if you define, I think you can do this in Haskell, right? It's basically where you define it without actually putting the identifiers in. So for example, yeah, if you define this, yeah, instead of g of x, you just write like g equals f. So if we're trying to define an operator that's like, I just think of an operator. I don't know, like a op factorial of n that's, I think, hopefully this is actual Ivy syntax. So n, so I think we say like if n is 1, 1, we'll try actually writing this in Ivy in a second. In, and then else we say fact of n minus 1, right? Or I guess in, let's say n less than or equal to 1. Otherwise we call it recursively, or n times, okay, n times fact of n minus 1. Let's see if that actually works. Okay, that does work. Yeah, so the idea, if we did it in point freestyle, right, we would just say like op fact, and then you have to, what do you do? Maybe this doesn't make any sense, but basically you leave out n. The point for alternative would be not to talk about the argument x, you just say increment square. Maybe this is a bad example. I'm not really sure how you leave out n here. But the point, the idea at least, is that you define an operator while leaving out the names of the variables, which would be kind of cool. But we won't worry about that now. Maybe the J, maybe J has a better example. J point freestyle. Tacit programming. Let's look at an example. So of course here's the example in Haskell. Yeah, look at that. So instead of sum being that, oh, maybe it lets you write it without even this base case. Function composition. Look at that. Beautiful. APL family. In J, the same sort of point-free code occurs in a function made to compute the average. Yeah, so plus over. Sums the items of the array. Mod number. So I guess basically every operator that requires an argument, you just put it in there. So this is the kind of thing we're looking at. So if we wanted to define this in Ivy, right? I keep having to zoom in, but like the average, let's let's see, 1, 2, 3. I really need to install, oh boy. I really need to install RLWrap. Okay, IV, so let's say x equals 1, 2, 3. Let's sum over x, 6. And then divide that by row of x. Yeah, that's right. So if we want to define average of x in Ivy, we would say sum over x. Oh, but we have to parenthesize this. Sum over x, because we want to compute that first, and then divide by row of x. So average of x is still 2. But if we defined it in point free style, right, we would just say plus over x over row x. Like this. Which would be kind of cute. Sorry for the big tangent. Maybe nobody cares. But it's something I've been thinking about, because I thought that was a really neat thing in J. Okay, fun.write, idents 2. Now we actually have to modify the context. So I have to say self.context.declare fun.left. I spelled declare wrong, of course. And then we do the same thing for right. It looks like I have to borrow that. Okay. There's no way that works. Oh, I just did an import hash map. That's pretty funny. So one to do here, oh boy, is we may not need to use the standard hash map. We might be able to get away with using one of the faster, non-cryptographically secure hash maps. We'll just, eventually, if we get this to work, we will actually do some, profiling on this. So let's say install map equals self.context.binaryf. Oh boy. Cannot move out of index. Great, great. Why did we even bother with this? Yeah, so this is not, it's behind a reference. Oh, God. I think we're going to have to use a cell for this. Okay, maybe mutated through shared references, whereas most REST types can only be mutated through unique references. So, the more common... Yeah, I think we'll just put a cell inside of this. Okay. So, okay, this is fine. I guess we'll just clone. Although I don't think we use idents again, so probably it's fine to move out of it. We'll see. That's something I had trouble with the other day. It's like I have them in a vector, and I just want to like move them out of the vector. Maybe I shouldn't have put them in the vector to begin with. And I guess we can't move it out because we have to like put something back in its place, right? Remove. Okay. Context. Let's go look at context. Now, the reason we can't just take this to mute is if we go back to main, our parser has a reference to context, but our scanner also has a reference to context. And we pass this context straight into run. So I think what we're going to just do is we're going to make this a cell. I guess we want this to be a cell. Now I have to try to figure out how to use this. Inside shared pointer types to reintroduce mutability. Maybe I just need to look at RC. Okay. So it looks like we want introducing mutability inside of something immutable. Yeah, it looks like we're going to need an RC ref cell. Okay. Or do we just need the ref cell? What? Oh, of course. Does that compile? No method declare. Well, that was easy. Okay. Unknown field. Context. Self.context.binary fn. Dot borrow. There we go. Whoa. Cannot borrow data. So this could be wrong, but the reason I'm doing ref cell instead of arc is because I think I actually need to mutate the context. Whereas my understanding of arc is that it just gives me reference counting. So, I don't think I need to... So when I think of RC or arc, I think about, like, I want to leave the thing alone and not mutate it, but I want to be able to clone it cheaply. And I think in this case, I don't really want to clone anything. I want to actually, like, mutate the original thing. And I could be totally wrong. Maybe arc is what I want. But this made more sense to me for that reason. And it might be telling me basically to use arc here. Let's see. Okay, cannot borrow as mutable. Yeah, does that sound right to you? I might have to grab some of my Rust books off the shelf to figure this out. Okay, deref mute is required to modify through a dereference, but is not implemented for context. Okay. Yeah. Oh, and okay, so it looks like maybe we're both right, and maybe we need to just follow the documentation, because it looks like we might need... Yeah, it looks like I need to take this reference off. So we might still need to use an RC. Ref cell. Because I think I do need a reference. Ref cell. Yeah, sorry, I hope this isn't too painful to watch. But I guess if anybody watching this is screaming at the screen the right answer, please go ahead and type it. I'd be happy to get it. I think this is probably what we want. Yeah, because I don't want to move. This might need to be an RC context. Ref cell new context. Can you do like from on this maybe? Expected struct context. Yeah, now the issue, of course, is that now it's expecting like the context itself, but to give parser new a context, we have to like clone in the context. So maybe, wow, this is confusing to me. And this, I think I talked about this maybe in the last stream or the one before, but this is probably another situation where I should not just be copying the Go code. This is probably a time when this problem should be rethought in a rusty way, not just trying to follow the Go code. So this is an issue you can run into, I think, here, where when you're translating programs like this, is that Go is being really loose with things like lifetimes and mutability in a way that we can't be. So we have to somehow try to specify for the compiler what Go just does freely. It's like, oh yeah, I just have this context and I can modify it however I want. But we have to actually describe how we're going to do that. So this definitely needs to take some kind of context. Oh God. RC new, ref cell new, hash map. Maybe we have to do the ref cell up above. Okay. And we're not worried about thread safety yet, because this is all going to be single threaded for now. Okay. Maybe mutated through shared references. So I think we may actually want to create this cell up above by moving values in and out of the cell. One must use the ref cell type, acquiring a write lock before mutating. Okay, so we might actually want, this might need to be a cell when it comes in. I should put this back. Okay, and now we can just use this. Now that will change our main. Okay, of course. And I think token, yeah, token includes a string. Where do we use peak? Where do we use next? So what I'm wondering right now is if a reference to a token is good enough. So where do we use next? It looks like we actually need a real token. So this is supposed to be this. Okay, again, I mean, it looks like this is probably bad, probably dumb. I just want to get rid of these stupid warnings. Self.scanner. What? Oh. Oh, no. Now that might be fine, actually. Maybe we can... No, we're gonna have... Do we have multiple references to the scanner? Okay, it's just the one. So if we only construct this scanner and hand it to the parser, let's just make this hold the scanner itself. Parser, scanner. Great. Can't move out of this. Okay, another clone. Terrible. Can't borrow this as mutable. Whoa. Okay. Now we have to find where this is used. So it has to always be mutable. Okay, mute. Great. Okay, we're gonna have to fix that. This has to be mute. Self.context. Okay. And I think we do have to clone this. Oh, apparently we can't clone this. Oh, because function is not clone. Okay. Let's derive clone then. Okay. P has to be mutable, of course. Okay, we'll call this next token. That's fine. Well, let's hop back to run for a second. If interactive. Oh, this is not supposed to be inside the if interactive. Okay, we call p.line. Why is it mad? What is this? Oh, okay, sure. Go back to line, go to parse error, derive debug. Okay, great. Now, do we, okay. If not okay, return true. What is true supposed to be? Oh boy. Typical execution. Loop until it succeeds. Oh. Okay. If not okay. Return true. Loop until it succeeds. So I think we're supposed to return okay. A little bit unsure. That makes sense, I guess. Run. Okay. If not okay. Alright, let's just match it for now. Okay. If it's an error, then I just return okay. Wow, that's weird. Okay. Otherwise, I think we actually want to do let okay expers equal p.line, else just return And then we can use expressions. If expers dot is empty, if it's not empty, so if expers is not nil, because we look back over here, a nil slice means there were no values. So if it's not empty, if it's interactive, start now. We'll skip the CPU time for now. Let values equal context dot eval expers. Set CPU time. All right, well, let's just skip the timing for now. Okay. What? Oh. Okay. Okay, we're just gonna skip that completely for now. Okay, values. Okay. Now it's gonna be mad about the missing else. Values. Empty back. Okay. If print values, what is this? This is probably looking in the config, right? Print values. Conf. We won't pass the writer because we're just going to use standard out values context dot assign global. Oh, very cool. Values dot last. Okay. Wait. Oh, is this? Okay, this is safe to call. Safe to unwrap because print values should checks that we have at least one. Don't make me clone it again. Wait, what? Supposed to take a value, and what is this? Oh, value just doesn't implement clone. Great. Now context needs to be now values, borrow of moved value. Okay, this needs to be borrowed. Now Clippy's gonna be upset probably. Okay. Context assign global. If not okay. Where did we get okay? Oh, that's the first time we check okay. Oh no, are we supposed to return expressions? No, I think anytime. Yeah, let's look for okay. So anytime you say okay false, it's always nil. False, nil. So there's not an occasion when we need to return like an error holding expressions. Okay, so we already handled that actually with our let else. Now what's the problem here? Okay, we'll try to sort that out in a second. If interactive, if not expers. Oh, this is just printing the time. Forget the time. CPU time. Yeah, I don't care about that. Although I think we probably need to if interactive print line. Okay, so let's go into print values. This is kind of exciting. Neatly prints the values returned. We might be about to actually use this thing. Neatly prints the values returned from execution, followed by a new line. This does not handle the debug stuff yet. If values.is empty and false. We don't care about debug yet. Values. Yeah, so this is that typecasting thing we had earlier. If v.assignment, so don't spit it out if it's an assignment. We'll just put a to-do here. To-do, filter out, printing assignments. But I don't really mind printing the assignments. I mean, I think a lot of REPLs do that. Let s equal v sprint f con. Oh boy. Okay, to do. So we'll just do some default handling here. Whoops. Float f. Oh, I did this badly again. Right f. D. And we'll leave the to-do on that one, actually. What's the problem here? What? That's kind of weird. Oh. There we go. That should be fixed. Let s be this. If printed and s.length greater than 0, and s dot last. Oh. fprint, not print line. Alright, what's wrong with this? Cannot be indexed. Okay. I guess we want s.chars.last. Oh, actually, I think we can do s.ends with. Not s.ends with. Okay. Then we print this. Okay. Printed is true. If printed, print line. And then we return printed. Great. We don't use the config for now. With this to do. Okay. Clippy. Lifetime, or value. Oh boy. Requires a tick 1. So we might just need to put a lifetime on this. Okay, the lifetime of this reference is tick 1. This is tick 2. P.line requires a tick 1. What's outlive tick 2? Okay, so I think maybe we just need to put this. There. Oh, okay, great. Length comparison is 0. Arguments are incorrect. Okay, yes. Parser new. It needs a ref cell context. Scanner. Okay, we can just give it the scanner. Okay. This needs to be mute, which means that this needs to be mute. And this needs to be mute, which means that this needs to be mute, which means we can't give out this, which means we can't do this. Okay. So I think our scanner is going to need a... Oh boy. Yeah, and we moved it. Holy moly. Okay, maybe this needs to be an RC, like we were talking about earlier. But they do RC ref cell. Yeah, this needs to be structured much better, I think. Probably what I would do if I had written this from scratch is, especially in the case of the scanner, one of these uses the context, but it never, so we're just checking stuff in the context, right? Oh, but this needs to be updated when the context changes. Ugh. Okay. Let's make our context, let's just do what they say. RC new on ref cell new of our context. And we'll just put that everywhere. Okay. Scanner new. Shared map, borrow mute. I feel like this is telling me what I need to know, but I don't feel told. So I'm just wondering if I clone the RC, therefore any mutation that happens in the clone method must use cell types. RCT maintains its referent counts within a cell. Ref count, cell. Yeah. Okay, when we clone. All right, thank you. Have a good night, I guess. Thanks for stopping by. Checked add one. Oh wow, dynamic thread. Do we need the RC or just the ref cell? I think we just need the ref cell. Now we need to borrow mute. No, 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 no. Does that work, really? I don't think so. Moved value. Yeah, maybe it does have to be an RC then. And then we can just clone into all of these. What? How does RC work? Am I being dumb? I mean, I am definitely being dumb, somehow. But there are, like, levels to how dumb I'm being, I think. It kind of feels like using this at all is dumb. But I've accepted that level of dumb. Ref mute. We need the RC. Why do we need the RC? Very common to reintroduce mutability. Shared pointer type. I guess that's why. Okay, so let's make... Oh, I guess I have to clone this now. Is the type wrong? Yeah. Parser. RC. And now this also needs to be RC. This is a disaster. Why is it borrowing it more than once? I gotta close the blinds. Parser was mutably borrowed here in the previous iteration of the loop. Okay. So I guess I just give it the parser, right? I feel like, I guess we need to look at run and see what we're actually doing with parser. Like if I go look at parser.line, it takes a ref. Oh. Well, where does this expression come from? I guess this is just supposed to be like box. I think this is the issue, is that it thinks the reference to this expression, okay. I think this is the issue right here. But I'm gonna have to tie this lifetime to something, right? Does that work? Okay. So I just want to pass in the parser. Okay. Okay. So we just give it this. Tick A. Now, parser doesn't live long enough. Now that doesn't make sense. Okay, let's look at line. I guess this just needs to be a box, right? Just do box din expression, and then I can get rid of this tick E. Okay. Oh, come on. Boxed in. Is it this? Now it's back to this. Parser is tick A. Do I even need this? Parser dropped here while still borrowed. Oh, I forgot the comma. So maybe we just have to return our parser, right? Wow, this is annoying. Alright, I'm just gonna undo a bunch of stuff. I think the RC is right. Can't find... Let's fix that. Parser. Okay. I really think... Let's see. Maybe run should just be a method on parser. Do you think? What if this is just impl parser? And we just say that this is a ref mute self, right? Parser, and then I just go down here. Let's do this, right? Impl parser, one generic argument, impl read. Okay, R is read. Okay, we have to just say R. R is read. Okay, let's give that a shot. Can't find P self. Yeah, great. Here we go. Disaster again. Tick 1 must outlive tick A. Okay. Ref tick A self. Great. Does it work now? Probably not, but let's see. Parser.run. Of course not. Yeah, of course. Okay. Wow, this is crazy. I really don't know what to do here. I just don't see why the borrow is still around. Maybe that was the issue? No. Okay. But what does this return? Why is it still borrowed? That's what I don't understand, is why it's still borrowed. Well, I guess this is definitely what people mean when they say fighting the borrow checker. I'm kind of at a loss here. I wish I could get a little more output here. Cannot borrow parser is mutable more than once at a time. Like, why is it still borrowed? I mean, I can call it once, right? Okay. Cannot borrow parser is mutable. So why is it borrowed more than once? This is quite frustrating. I'm getting kind of upset here. Actually. Yeah, it's like, why is this still borrowed? Let's go look in run. Okay. Yeah, this is why I should have committed before I started doing this, because now, I mean, it'd be nice to restore to some kind of earlier value, right? Okay. You know, I mean, I think I really just don't know. Cannot borrow. Well, I mean, if that's the case, then here we go. We'll just never return. Yeah, return OK. So we're just gonna put this. So we'll keep the context here. We'll just put the loop in here. Okay. So error means go again. So just take that out. When it says return OK, we just say break. Okay, self-taught line. Can't borrow self is mutable. So this is the issue right here. It's this line thing. This mutes self. And I think it's because we're returning something that refers to self, maybe. What is expert? Expert, I think this is the issue, right? This is tick A. And self is not tick A. Shadows a lifetime. Oh, let's call it tick E. The expressions should not be tied. Okay, wow. I think this is the issue. Now these are tick E. What are these tied to? These are tied to the context. Okay, hold on. Okay, where's my context? Okay, my context is, we're going to call this tick C. Okay, and the scanner, oh, it is supposed to be the same, isn't it? Why does this have a lifetime? Because of the config. Oh, this is a mess. This is a mess. Okay. Wow, this is a disaster. Okay, let's go back to the context. Let's call this tick conf. Okay. The function's lifetime is tied to the expressions. These should not be, no, this should not be tick A. Take off this. This should just be box. Box din expression. Okay. Now the expression is tied to a context. Context is tick conf. This, we don't even care about this lifetime, right? Yeah, the functions don't care about the lifetime. Okay. This is box. Yeah, I think I just got carried away with my lifetime stuff. Well, both carried away and, like, not carried away enough. Because, yeah, I mean, I just didn't think about it. Like, these lifetimes, I use the same lifetime everywhere. And that's just not the case. Din value content. Okay, so it has to be din expr plus clone. Only auto traits can be used as additional. Oh boy. Din expr. And what is an expression? Yeah, I think this should also be an enum. Where do we import expert? It looks like we don't import expert. Where do they import expert? So you can have a slice expression, a variable expression. Oh, can be made into an object because it requires self-sized. Oh, geez. Trait bound clone. Okay, we can't clone functions. Great. Let's just take off this clone. Cannot move out of it. Okay. What are we going to do with install clone? Oh, install map. Prev defin. Yeah, I think we just... Oh, man. Okay, we need to just not do that. So what do we do with install map? Let's just go back down here for a second. Okay, hold on. So the point is basically okay. Let's just write this and then we'll see how we can fix it. Okay. Self.context.borrow mute.define. Okay, so we're going to define it, but prepare to undefine if there's trouble. Okay. Oh god, defer p.context.forgetAll. So we're going to have to remember to come back and do that. Succeeded equals false. Let prev defin equal install map.get on.get. Okay. I think we need to go to function. Yeah, we're going to make this called enum expr impl expr. Great. Let's replace box bin expr with expr. Yep. Okay, this should be x. All right. Yeah, we're just giving up on this trait stuff. Expr pub. Great. Unused variable context. Perfect. Self.borrow, because this isn't copy, but if we go look at this, function can now be cloned again. Expert can now be cloned again. Can't move out of this. Oh, why did I do that? Okay, so now we can clone it, and we can clone it. Great. Now let's go look at define. Does this really need to take it? Fun.name. Insert. Yeah, we're really putting it in. So I guess we have to, well, we can just say let name equal fun.name dot clone. Okay. And now we can use name. Right. Okay. Did we fix everything? This is just insane. Okay, our parser is tick A. So we're saying the scanner has to live as long as the parser, and the context has to live as long as the parser. Okay, if we go into our context, it has tick conf, so our config also has to live as long as our parser. I just do not get it. I just don't get it at all. I think it's because we're saying, what if I just get rid of this? Can I just get rid of it? Oh, I'm saying this reference. Can this just have like a different lifetime? Lifetime may not live long enough. This, maybe this is just like tick static. No? Okay. Let's do tick conf. This is tick conf. This is tick A. And this is tick conf. Tick A must outlive tick conf. Okay. Adding the following bound, tick A is tick conf. This is ridiculous. This is just ridiculous. Let's undo a bunch of stuff in here. We need to return something again. Okay, this is just gonna take self. Fine. Can we fix it, please? Oh no, I just got rid of the stupid, yeah, of course. Okay, so it gets moved. Okay. Okay. We got it to work. It compiles. Okay. Can't happen. Pause. Okay, we messed something up. It doesn't work at all. But here we are. Can't happen. Okay, so self.pause is always greater than self.start. What the heck? Let's just debug self. Can we do that? Probably not. Scanner. Scanner. Self. Scanner. Derive. Debug. Alright, let's copy this. Value. Debug. Function needs to be debug. Opdef. Debug. And expr debug. Is that the last one? Okay, sure. Or sure, make it also debug. Perfect. Next token. Oh no. Next token not found for this struct. What? Oh, it's because, okay, sure. Read plus debug. Wait, what? I shouldn't have done this. Why did I do this? Wait, it's right here. Oh, I have it here. Yep. So where is it? Prompt. Seed bits digits. So we're looking for can't happen. Self.pause. Where is pause? Pause is 1. And start is 0. Ooh. If pause greater than start. How does this work? Back up. So we're calling back up sometime when we shouldn't, obviously. Also, our prompt's not working, but what can you do? 2? Okay. This is called... Okay, so we're calling back up. Great. Calling back up in fall through. Let's go to fall through. Where do we call back up? We're in fall through. We call fall through here. Okay, maybe we need fall through. Let's just do debug LR. Two. Where are L and R? L is this scanner, and R is 50. Okay. Maybe we should just print R. Does that work? 2. 50. Can I do this? I'm guessing it's 2, right? Yeah. Okay, so the character's 2. If... Oh, maybe this is supposed to be not contains. Let's look for backup. Except, so this is probably... so it's a 2. Okay, it shouldn't be this. Oh, it's... Okay, it's in this fall through case. 0 is less than or equal to R. I'm supposed to call L.backup. Alright, let's look at this. So, okay, we're supposed to call L. Is this even... Okay, so we're supposed to call L.next. Did I forget to call it? Oh, no. Hold on. So we're in Lex. We're supposed to be in Lex any. Let's factor some of this stuff out. But we can't because it does this. Okay. I guess we're in Lex any. Print line in Lex any. Okay. So we're in... Okay, Lex run 499. Fall through. Okay, so it doesn't match any of these. We're in Lex any. We didn't return none. It's not a new line. It's not a semicolon. It's none of this special stuff, right? So we fall through. Alright, when we fall through, we print the character, which is a 2. Okay. So we're in this, so we call back up. So where were we supposed to set the position? Or where were we going to back up? We say if self.pause greater than self.start. Pause greater than start. To do can't happen? Question mark? Maybe it can happen. Should only be called once. Is this supposed to happen or not? Our position is greater than the start. Okay, maybe it just can happen. Let's see. To can't happen is the comment from Go. Okay, let's give this a shot. 2. Okay, great. Oh, great. Parse. Not implemented on line 106. Okay, great. We actually, we can do some stuff. Do I have debugs in here? Where was that print line? Two. Great. This is great. It would be nice to know actually. Let's give this a shot. Print line. It's happening. It's happening. Okay. Okay. I don't know why this says can't happen. Okay, it definitely can happen. It definitely can happen. Whoops. It's happening. In fact, it happens a lot. 2, 3, 4, 5. Yeah, it happens a lot. Okay. Good. Wow, that's good to know. Okay. Let's just maggot blame this. What did this used to be? Well, I never really understand how that works. How long have we been going here? 3 hours. That might be enough for today. I don't even know what we did. I don't even know what we did. I think we took out the loop though, didn't we? No, here's the loop. So we put the loop back. We fixed all of this. We made it take debug everywhere. I don't even know. This was a mess. We got rid of a ton of lifetime stuff by making expert an enum. I don't even really know. Okay. Whoops. Cargo run. 2. So I guess now we can actually do this though. Parse. Yeah, we can use this to show us what to look for, or what we need to implement. So every time we hit something that doesn't work, every time we hit something that doesn't work like that, we just implement it and then try again. Okay, this is a tab for some reason. Let expers equal p dot statement list. Let talk be self dot next. Now this has to be mute. This is self match talk dot type. EOF. Oh. Okay. If talk.type is UF, F, self, unexpected talk. If not, expers dot is empty and self dot context dot borrow dot config dot debug. Okay, we don't actually care about the debug. Okay, to do debugging tree print. Otherwise, we return expers. Type is a type. Make is. Okay. Generate this. Statement list. It has the same return type. Where are we? How would it be nil? Oh, it's not peak. Oh. This is a nightmare. Holy moly. Oh. Okay. Anyway, this is fine. Exper returns and exper but it can be nil? Oh geez. How would this be nil? Okay, so we actually can have a nil exper. Okay, statement list. If not exper dot is nil. Self dot peak. Type is type colon implements expr through embedding. Oh, great. What is binary? It's a struct. Do I have a binary struct? Well, we'll just build it up the same way. Conditional, which contains a binary. No. Parse binary. I am not sure about this. Conditional contains a binary, which is a binary that contains an op. How do we make one of these though? Oh, binary. Okay, here we go. Op is toke.text. Okay, hold on. So we got struct binary as an op, which is a string. It has a left, which is an expr, and a right, which is an expr. Okay. Op left is expr, right is self.expr. Okay. So expr can be a conditional which holds a binary. What's going on now? Oh, unexpected closing brace. Conditional close, close. This closes the if. This is not supposed to close the if. This conditional. This closes this. Okay. All good now? What? Oh, it's a trait. Ugh. Oh no. Binary. No. Binary. We need to import. Oh boy. Pub, just make everything pub. And this needs to be pub. What? What's the problem? Binary. Have infinite size. Oh god. Yes. That's true. Great. I've seen this before. I know this is possible. Yeah, I think you just put something in a box. Yeah. Okay, just make it a box binary, I think. Is that fine? The trait bound. Okay, this needs to be clone. I guess this doesn't need to be pub because it's implied. Alright, there we go. Binary. Now I can import this. Value context binary. Does this work? Mismatch types. Expers is supposed to be this. Expected result. Oh, wrap it okay. This is binary, but it needs to be a box. And this needs to have a unit. There. Whoops. Okay, so we took care of binary. Okay, there we go. Now, once we've done exper not nil, let mute exper is equal vet new. If exper, if not exper dot is nil, expers dot push exper. Okay. What's the problem now? Yeah, that's fine. If self dot peak dot type equals type semicolon, then self dot next, and we recurse. That's kind of frightening. Let more equal self dot statement list. Okay. If let some more, then expers dot push. I think we're gonna have to. So more is gonna be. Wait, shouldn't statement list return? I think more should be a vector, right? This probably needs to be extend. Okay, we'll come back in a second. Yeah, extend. Okay, and then we return okay, expers. Okay, there we go. Great. Okay. Now we need to implement exper. In case you guys are curious about these comments, I think this is like a description of the language's grammar. I think Rob Pike talks about this in the talk I linked. How you just like write that down above the function and then you implement it. Equal self.next exper equals self.operand. It just keeps, it goes deeper and deeper, doesn't it? Okay, operand is supposed to return an exper. Yep, to do. So we just like keep kicking it down the road. So we can return a binary directly. What's the matter here? Is everything okay? Oh, I have to say toke.text. Why didn't it format it? Oh. This is the identifier. This is the match. This is the function. Oh. Okay. So just not everything's handled, which is true. Okay. Assign. Self.next. Just consume a token. So we're doing a type switch. I think I'm going to make a module for this. This is inside. Why is this inside context? So confusing. Anyway. Expert. What are we supposed to have in here? Conditional, binary, variable. What is this? Variable expert. It's supposed to contain a name and a local. Okay. Variable expert. Or we can have an index, which has an op string. Why did I do it like this? Unclear. Op string left expert. Isn't this a binary as well? I guess this is just a binary box. Binary. Okay. Sure. Match expert. Expert. Variable expert. Index. I'm not sure we can do this. Oh, can you do that? Okay. case. So we're inside a sign. Okay, so we're going to check expression. Okay, if we get one of these, we just return a binary. This is so weird. Index. Yeah, index is an expression. Yeah. So we return LHS. Yeah, box. Let's just go make a constructor for this. Binary. Pub f binary takes a up string left expr right expr, and it returns a self. So it's going to do the thing that we keep doing. So it's going to do it's going to return a self binary box new binary up left right. Okay. What? Oh, binary. Perfect. So I can do return expr binary of up left right. But I have to actually see what left and right are. Up is toke.text, left is LHS. Oh, this is supposed to be expr. And right is supposed to be self.expr. Okay. If it's not one of those, then I say error f self cannot assign to expr. Okay. And I'm also, okay, so assign. Now we also should handle operator. So next. And then here we return an expr binary of left talk.text. Left is expr. And right is self.expr. Okay. And if none of those matches, we just do error f. Oh, we're going to need this, of course. As we keep finding out, self after expression unexpected self.peak. does this have? 673. Operand. Whoops. Wait, how did this get down here? Oh, it looks like I lost something. Okay. Takes a token, takes an index, okay. We can't do that. Okay, let's see what a unary is. These don't even have to be pub anymore. These names are not very good. Okay, if unary takes an auct string and it takes a right expression, returns a self, it's going to return a self unary, which contains a box named unary no, this must go here. There. Great. What's this? Okay, I see. Unary should be good. What's wrong here? Mutable, of course. So we handle operator. Now we can also give an identifier. Define unary text. Borrow here as it tried to show us. Then I'm going to return expert unary of talk.text self.expert. Okay. No. Okay. Otherwise, number, or rational, or complex, or string, or left paren, then we're going to return self.number or vector of token. Okay. Otherwise, we have to wrap this again. Error F self unexpected token. There's number vector. Okay. Oh, we're not actually supposed to return these. Oh no, we were supposed to fall through. Oh geez. Okay. Operator. So this one's fine, we just give this. Otherwise, if this works, we break. Else, we fall through. To this case, oh, I do need to comment that one. I always forget how fall through works. Does it go just to the next one, or does it go? I think it just goes to the next one. Fall through. This thing. So we're thinking fall through. I think it just goes straight in, right? It doesn't check the case. Yeah, okay. I mean, that wouldn't really make sense. So, okay, it just goes into the body. So we'll just call it here. Okay. So we get all of this, right? And then, if index okay, expert equals self.index of expert. So this needs to be mute. Wait, why do we even bother with all of this? Oh, I guess because it consumes stuff, right? And then finally we return expert. Now we don't know what this is. Okay, where is number or vector? This one looks kind of complicated. Let's go back to index. Okay. I think we're almost done with this big file though. Readme. Parse. Yeah, this is one of the next largest ones. Let's see how we're doing here. Cargo. Whoops. 2. Parse 278. Yeah, number vector. Well, yeah, but again, index is easier. We'll do that one first. Okay. While self.peak.type is type left bracket self.next. Let list be self.index list. Oh no. This is why it's easier, because it's probably actually longer. Is this how you make a matrix? 1, 2, 3, 4, 5, 6. No. Let talk equals self.next. If talk.type not equal type right bracket error f self expected right bracket found this token. Okay, otherwise, oh boy, mute expert equals an index expert. Index is another. Okay, hold on. This is a very handy pattern I learned from John Hu. We're gonna take fn name, which is an ident, and a variant name. I guess it's also an ident. Okay, and then in each of these, it's gonna have star, star, star. Okay, so for each of these, we're gonna make a pub fn name of off string left expert right expert returns a self. So we'll say self. Oh, can we do this? I bet we can't do this. Maybe we can. Is this okay? Pop F in. Oh, I think I forgot to do this. And so then we should be able to use this like this. Binary holders of conditional, like that. Oh, I forgot to put this in here. Yes, multiple definitions, fantastic. Did it work? Oh, I shouldn't have deleted it yet. Hold on. It takes a binary, which is a box new binary of up, left, right. Great. Now each of these becomes this. Great. And we did that for a reason that doesn't even work. I thought we were about to have another one of these. Oh no, we do. We have an index with no name. Expert. What is list? Index list. Oh no. Index. Oh, this is not a binary. Okay. Well, it'll probably come up again anyway. Post-struct index has an op, which is a string. It has left, which is an expr. And it has right, which is a vec expr. That's the part I didn't notice. So index is actually an index, which is a box index. Okay, great. And now if we come down here, index takes op, op is a string, left is an expr, and right is a vec expr. Okay, self index of index, which is a box new index, up, left, right. Okay. Expert index. So we're not giving op. So it doesn't have a name for some reason. And then at the end, we would just return the last expression. Now it has to be mute, of course. Index list looks like this. I'm just going to call it scene. Lots lots of infinite loops, huh? Let toke be self.peak, match on toke, use type star, if we get a right bracket. Sorry, this is probably really boring. I guess I'm kind of tired, but I just don't feel like stopping yet. But I don't think I'm talking very much. So, apologies in advance. This is mostly pretty straightforward code. The stuff we were doing earlier really took it out of me, I think. If not seen. Yeah, that's a good point. I was just thinking that I'm not really explaining anything. I guess if you're just tuning in, what we're working on generally is a Rust translation of this program called Ivy, which is an APL-like language. Yeah, you can step through, you can do like math and stuff. You can have vectors, you can add vectors to numbers, stuff like that. And so what do we have? What I have here on the right side is just the Go version from GitHub, Rob Pike repo. And we're just translating this from Go on the right to Rust on the left. And at the moment, I think it's pretty straightforward. We're just making these conversions, the translations. So index list here. This, we've got like a parser. In our case, we're inside an impl parser block, so we've got self. Instead of returning a slice, we return a vec, that kind of thing. Yeah, so this is a pretty boring part of it, where we just, pretty direct translations. Earlier in the stream today, we had a really hard time fighting with lifetimes, with the borrow checker. So if that sounds more interesting, maybe go back to that part of the video. Right now, probably I should do this stuff off camera, because this is pretty formulaic translations. Except for some of the stuff we've been doing, where we come over here to expert, and so their expert is actually an interface. This is pretty interesting. So this is an interface. Yeah, that totally makes sense. I've meant to record like an intro for this series that I can point people to, but I haven't done that yet. Let's see. So yeah, something that's kind of interesting about what we're doing now is that in the Go version, expert is defined as an interface. And so the first version I wrote of my expert was defined as a trait, which is like the similar concept in Go. But they're using, for example, these values, they have slices of multiple expressions that are not all the same type. So that means if our expert were a trait, if we have like trait expert, then we could write vec of e. Let's just imagine we have like fn takes expers like this. We could use it like this. E is expert. However, this requires that the whole vector has the same type of expression. So what we ended up doing, well, what I did at first is I was trying to use ref din e, which requires expert to be able to be made into a trait object, which this ref din is. And when I use the plain reference, it also required this lifetime bound. So it was really going crazy. So we switched to like box din expression, and even that we were having trouble with. So what I've done instead is gone away from the trait version and gone to this enum version. So now we just have variants of basically we have variants that match up with every type they have that implements their expression interface. So a lot of these look the same. So this was kind of a neat thing that we just did, I guess, is we made this binary holders macro. And I'll have to try to find where I got this from originally, but it was I was watching John Hu's one of his day in the life of open source maintenance streams, and he wrote something like this to replace a bunch of boilerplate code like what we had before, where we had like multiple very similar definitions. I mean, we still have some pretty similar definitions, but they're not exactly the same. That's good to hear that the enum seems more elegant. I always feel like the trait would be more elegant, but it's really complicated. So I'm happy if maybe the enum's more elegant. So then it's the perfect solution. Maybe I'm just looking at it wrong. Yeah, I mean I think this is right, because in one of my previous streams on this topic, I googled like when do you use an enum versus a trait, and I guess the rule of thumb that came up from a Reddit post was you use an enum when you want to like close the universe. So we're enumerating all of the possibilities, and that's clearly what we're doing here for an expression. Whereas a trait would be like I'm describing the properties that an expression has, which lets other people add more expressions. So yeah, I guess the enum is really what we're going for here, and Go doesn't really have like a full enum feature. They have this like iota stuff, which we probably have some in here. Maybe not. I know we have some in the project. Maybe not in here. Yeah. Okay. So maybe thanks. I think you made me feel better about using the enum. But anyway. Let's see. Hopefully, okay, so there was some explanatory content. So now that we did some of that, let's get back to our index list. And I guess one more thing to touch on is that basically, well, okay, so right now we have a syntax error, but we're at the point where we have the scanner is finished, the parser is partly implemented, and we have like two operations defined. So what I'm trying to do is I keep trying to run it, and then when it panics or hits a to-do, we just go back in and we're trying to fill in those to-dos until we can actually run it. So, well, let's try to do this part, and then we'll try it again. Index list. Right brack. I already did the if not seen thing. If not seen, list.append. Whoa. We're appending nil. I don't. But we have a variant defined that's nil. Expr nil. Okay. I don't know why I typed that. Push. Okay. And then we're going to return that list, actually. If not seen, return list. If we get a semicolon, self.next, if not seen, list.push. Nil. This is kind of concerning. Not sure. Expr. Seen is false. Anything else? We just list.push self.expr. Seen is true. So one other thing to say is that, what's the matter here? One other thing to say, I should also be explaining the code I'm writing. But in some of these cases, I don't really understand what's going on. I'm just doing kind of a mindless translation between Rust and Go, or Go and Rust, which is not good. So probably I should try harder to do that as well. I guess in this case, I mean, I see that we're taking like a list of expressions, Yeah, what is... I have no idea what this nil is for. I guess they say means all of V. So I guess just going by the name, right? Like index list. I guess... Let's pull up Ivy again. I think what we're trying to do right now... Let's see, we've got iota 5. Yeah. Oh god. I really need to install RLWrap because I keep trying to do stuff. Alright, let's do iota 5. And then let's look at 3, 4. So I think what we're doing right now is implementing the part of the parser that handles indexing with a list. I think. I'm not sure about that, so right bracket, semicolon. And I guess the semicolon maybe is how you index a matrix, for example. Yeah. I think that's what we're doing. And then, yeah, I guess nil, it's just saying that the... I guess it's saying that an empty list just means take the whole thing. I think. Okay. Found this. Yeah, exactly. If you index with an empty list, I think it means you just take the whole thing. Oh, I should... Let me try it in Ivy. I guess I should keep Ivy pulled up. But I'm kind of running out of tags. Let's see. Iota 5. Yeah, you get the whole thing back. Exactly. Yep, yep. So, I guess I'll put this over here. So, yes. That's why we keep this nil. Oh! I wonder if appending nil to a list in Go. That might not actually do anything. That might not actually do anything. How do they do it? Let's see. Value. V equals append V nil. Cannot use nil as int value in argument to append. Oh, it's because it's a... Okay. This is an interface. Sometimes putting together these examples is like... I can do an empty interface, right? Let's give that a shot. Hello. Nil. So it does just give you a nil interface. Alright, anyway. So we are actually supposed to push nil things to the vector. Alright, what's the problem here? I think this is our return value. Return list. I'm not sure what this error is about. Oh, yes. Wow, the compiler actually told me what I needed. And this has to be mute. Great. Okay, I think index list is done. So let's try running this again. Okay, I'll put a 2 in. And we panic at line 278 now. So we need to go implement number or vector. And I'm hoping actually that number or vector will... Well, it looks like we're going to defer to number. So we'll have to do number as well. But 2 is a number or vector, and it is a number. So I'm hoping that after we do number or vector and number, we might actually not crash. Well, we'll see. Okay. What is this? I guess it gives the string back. Okay. self.number of toke let you've done be true. Match self.peak.type. And let's do this again, type star. So here, I like it when the name tells you what it does. So we're trying to parse either a number or a vector. We're going to look at the type. So let's see, number, rational, complex, string, identifier, left paren. Okay, done is false. So we find one of these things, further vector elements follow, so done is false. Okay, great. So this is another switch with only one case. So I guess we can do matches. Yeah, we can actually say done equals matches number. I think we can do this. Or rational, or complex, or string, or identifier, or left paren. Awesome. Done equals false. This is actually not matches. Okay, let's generate this method. Not matches. Slice expert. Okay, so this is going to be something else that implements. So this is going to be another variant of our enum. Kind of weird. So let's add another variant. Can we do that? Okay, we can do that. Great. None of the other ones. We better just stick with this. We call it expers. Okay. Slice expert. So we'll just do let mute expers. New if exper dot is nil. I guess we can call it slice actually. Slice dot push eval string s. This is gonna be extend. Okay. Else slice equals expert. Oh boy. This is an expression, right? Okay. I guess we need vec of expression. Okay, where's eval string? Eval string. It returns a vec of exper. Runes are chars. So let R be s dot chars. Let V be vec with no vec I don't like that. We'll do vec with capacity. R for C in range R. R range is implied. b dot push c. Oh, these are supposed to be char. Oh, char is a rune. And char. So this is going to be another variant, actually. Okay, surely this can't compile, right? How does... Oh, right. That's one thing that's slightly annoying about Rust Analyzer, or maybe my setup with Rust Analyzer, is that, like, this error means it doesn't even look down here. I guess that makes sense, but maybe that's even like a cargo or Rust C thing. And maybe it's, I think it's only for like really bad errors. Number is supposed to do what? Okay. The error thing, that would be nice to be able to change. Whoops. Okay. Yes, now this isn't right. We have to push expert char. Now maybe char we will actually make. We'll actually make this like that. What's the matter? Found for Eno. What? Yes, good call. Oh. Yes, let's do, I think it's already an iterator, so we can just do map. Can we just do this? Or do we have to do something? Great. Yes, excellent suggestion. Okay. What is this? Number or vector? Yeah, that's much nicer, right? Good call. Number or vector. If expert is nil. So the fact, maybe these should be like options or results, right? It feels weird to be checking, you know, doing like a nil or null check in Rust. Append, else this. Okay. If not done, loop. Talk be self.peak. Talk.type. Left paren fall through. Oh boy. Okay. Identifier. I hate these fall throughs. Okay. Identifier, we're just going to copy and paste this time. If p.context self.context.borrow defined op of talk.text break outer. Otherwise, fall through. What's the matter? Oh, I forgot the colon. I thought I was missing something. Break outer value. No, that's okay. Okay. So, otherwise, fall through. So, we'll just put the same stuff in here. Let expr s equal self dot number of self dot next. If expr is nil, must be. I'm not doing a very good job of copying the comments either. Must be a string. Slice dot push. Nope. Extend. Eval string. Did I not generate that method? I did. Ooh, maybe not. Eval string of s. Okay. Continue. Okay. And then default break loop. Break outer. And then, wait, where's the other loop? Oh, we don't need this label. The reason they need it is because you can also use break to break from a switch in Go. But we don't use break to get out of a match. Default break loop. At the bottom of the loop, we do slice dot push expr. Okay, and this is done. And then after that, if slice dot len is 1, 0. That's kind of weird. I don't know. Can we do that? Slice. That has the wrong type. Oh, it has to be expr slice expr slice. Okay. That should be fine, right? Looks like I missed redefining. Oh, this needs to be mute, I think. I guess we'll make these both mute. And then take off this let. And this needs to be mute, so that we can call next. And we need to do this. Okay, I think that's good. Two. Yep, 374 at number. Already copied that. Great. Error. Let text equal tote dot text. Dash tote dot type. Use type star. If we get an identifier. we're going to try this. Hopefully this works. So this is also something I kind of miss from Go, is that you can like name the variables up here. It's kind of redundant in this case specifically because expert is an expert and stir is a string. But sometimes, especially in some of my other programs, if I'm returning like vectors or something, it would be nice to give these a name. I think the rustier thing to do is to define like a struct that's returned from this function. But sometimes that feels like overkill. But what is stir? If the value is a string, expert is nil. But what if I guess if... So this actually, to me, it seems kind of like an enum, right? Because in this case we set expert and never touch stir. In this case we only touch stir. In this case, we touch only expert. Yeah, so these are actually like exclusive. Whatever. But let's not think about it too much right now. String, then we do expert nil, and parse string of text. If it's a number, or a rational, or a complex, then we parse. We'll just unwrap that, I think. So we'll do expert. So this will be the second return value. And then we need to call something called parse. Self.context.borrow.config with text. Dot unwrap. Well, hold on. Let v be this. Oh. So we will call parse on that. We can use let okv be this, else we will error f. Text. Oh, right. We'll match this. Error E. Okay. This is so weird. Let me finish writing this and then I'll explain. V string new. Get rid of the else. Okay. So what are we doing here? So this doesn't exist. Basically, none of this stuff exists. Why doesn't this exist? String is a variant. Oh. Let's take this off. We'll say type. Okay, so this doesn't exist. Yeah, so what are we doing here? If it's a number, we're going to try parsing it using this config. Oh, and we have to give it our text as well. Text. Okay, and if it works, we should get an expression back, in which case we're going to return expression. and v. Otherwise, we're going to use this error case. So we're not going to wait till we get down here. We'll just go ahead and return, or we'll call error f here. And error f panics. So that should be fine. What else can we get? A left paren. So type left paren. Then what do? We let expr equals self.expr. We let toke be self.next. Now it's going to have to be mutable if toke.type not equal type right paren error f self expected right paren found toke. Otherwise, we'll return expr and string. Okay, and once we have expr and string new, we just return them, which means we'll just return this directly, I think. Oh. What if we don't match anything? If the value is a string, expr is nil. Parse string. Yeah, it's not clear to me what happens if we don't match. Okay. Nothing in the Go version. Maybe empty stir. I mean, let's see. So error is error. We don't even set error here. Oh yeah, so okay, let's say none of the cases match. Error will still be nil because we just put it here. So we'll just return expr stir. So expr will be nil, and string will be empty. I mean, I guess we can just return that then. Expr nil, string new. Where did I? Oh. Remove the semicolon. How did that get there? Okay. So self.variable. We can generate that now. And that's pretty easy. We'll just add another variant here. Now, parse string is supposed to go in the value module. Ooh. Value. Let's do pubmod char. Oh, but this is just supposed to be another. Oh, hold on. No. This is another variant. So we're going to put ours somewhere else. Ours goes over here. Yeah, char. And what is it supposed to be called? Parse string. Parse string. Parse is a string. Well, this doesn't actually have anything to do with. This doesn't actually have anything to do with the char. Oh. I think this is going to be from stir for value. Great. Yes, I think parse string. This is so... so it just gets deeper and deeper. Okay. I don't know. Parse, error. Sure. Oh, I don't know. That's fine. We'll do this later. Parse string of text. So we can actually do, what is this supposed to return? It returns another string though. Maybe that was wrong. Let's hold off on this for a second. Yeah, let's just put this in here. Parse string. Pub fn parse string. It takes text. It's supposed to also return a string too. Okay. Or value parse string. Okay, great. And now this, let's go back over here. Where are we supposed to get parse? This. Now this I think is our, oh, I guess I should have left the from stir thing. From stir for value. Maybe we'll call it a value error. I don't know. Derive debug. Great. This needs to be pub. Oh, but it takes a config, so we still can't do it. I'm just too excited to do this, right? We'll just call it parse, I guess. Clippy will probably get mad at me because Clippy will probably be mad at me because parse is like, you're supposed to define that with from stir, right? Result, and I should have kept the parse error. Okay, we'll just use the one we already have to do. Great. Import parse. Macro expansion. Yeah. Error F. This is something I don't really understand. No, it's something I just wrote. That one's fine. That one's fine. That one's fine. This one. For some reason, you have to do this. And this has been moved, I think. Oh, or it doesn't implement. Yeah, okay. Does it work? Okay. Variable. Okay. And this is... Okay. This is found to be of type expr string. This is found to be of type expr string. Value context expr. Value context expr. Standard string. Standard string. Well, that doesn't look right. I don't see the issue here. This is this. Oh, one of them must be wrong. A different one. Oh, this one's value. Oh, right. Of course. Parse value. Oh, I think value is parse returns a value, which I think is an interface. Yes. And expr. Yes, expr is an implementer of this interface. Okay, so parse needs to return an expr actually. Fine. Okay, so let's just do this. I think I'm probably, I want to finish this file, but I'm getting kind of tired. Okay, so somewhere I'm calling error f, I don't actually have a mute self. And again, it's in something I just wrote. Here we go. Borrow moved value. Where did text get moved? Parse. Let's hope this can be borrowed. If it can't, we'll come back and clone it later. Great. Clippy's happy. Cargo run. 2. Value. We're so close. Parse. Well, I think we're so close. Maybe not. Parse 2. Alright, alright. Yeah, it just keeps spiraling. I think I'm going to go ahead and call it a day. Yeah, it's been 4 hours. Let's try to write some kind of commit message. Big progress on parser. Let's see how many lines we're up to. We have almost 2,000 lines, and I think the total is like 12,000. So, in Go. There are like 12,000 lines of Go. We've got 2,000 lines of Rust. All right. Scan RS. How long is their scan? Ours is a little longer. So ours might be longer than theirs in the end. Okay. So we got some good progress. We haven't finished any files yet, so I don't really want to cross anything off here. Yeah, but that was pretty good progress, I think. Again, if we do cargo run, it looks like value is the next thing to implement. It's pretty exciting, I think, actually, that we can cargo run it at all, because we couldn't do that earlier before I started. But anyway, I think that's it for today. We'll come back tomorrow working on the value parsing. Hector, thanks for your help on that, the map and collect, and good to see you. Good to see everybody else too. Thanks for stopping by. I'll see you next time. Thanks. See ya.